Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Hakimi and I will be presenting the first question, which is explain the meaning of differentiation and what are the techniques of differentiation. So what is differentiation? Differentiation is a derivative of function given the role of the rate of change or slope at the function at any given point. Okay, so there's around 11 techniques of differentiation. So the first one, we have the constant rule. The second one, which is a power rule. We also have chain rule. We have generalized power rule, and we have product rule. So for the sixth one, we have sum and difference rule. For the seventh, we have the quotient rule. For the eighth, we have the trigonometric rule, which is the usual sine, cos, and tan. The ninth one is the exponential rule. The 10th one is the logarithmic differentiation, and the 11th one is the implicit differentiation.
I'll explain the question 2. The first equation is y equals open bracket 4x plus 2 close bracket to the power of 4 divided by sine of 5x. For this equation, we use quotient rule. For the quotient rule, if y equals u over v, then dy by dx equals u prime times v minus u times v prime all over v squared. Here, u is open bracket for x plus 2 close bracket to the power of 4. Its derivative u prime is 16 times open bracket 4x plus 2 close bracket cubed. V is sine of 5x and v prime is 5 cosine of 5x. Then we substitute everything into the formula. Dy by dx equals 16 times open bracket 4x plus 2 cubed times sine 5x minus open bracket 4x plus 2 to the power of 4 times 5 cosine 5x, all divided by sine squared x squared 5x. That's our final result for part A. Now we go to the second function, which is y equals 2e to the power of 2x plus natural log of open bracket 2x minus 1 close bracket. For the first term, the derivative of e to the 2x is 2e to the 2x. Then we multiply by the outside coefficient 2, giving for e to the 2x. For the second term, the derivative of natural log of f of x is 1 over f of x times f prime of x. Here, f of x is 2x minus 1, whose derivative is 2. So this part becomes 2 over open bracket 2x minus 1 close bracket. Combine both terms and the final derivative is 4e to the power of 2x plus 2 over open bracket 2x minus 1 close bracket.
Next, we move on to question 3. Question 3 given x power 2 cos y plus 5 exponent power 5x minus ln y equal to 5x power 3 plus 2. Find dy over dx using implicit differentiation. Procedure for implicit differentiation. Step number 1. Differentiate both sides of the equation with respect to x. Treat y as a differential function of x. Step number 2. Collect the terms with dy over dx on one side of the equation. Step 3. Factor out dy over dx. And step 4. Solve for dy over dx. In this equation, I found 4 terms from the equation. Terms number 1. d over dx x power 2 cos y. For this term, we use product rule. So let u equal to x power 2 u prime to x, let v equal to cos y, and v prime is negative sin y. So we put all together into product rule formula, and the answer must be 2x cos y minus x power 2 sin y dy over dx. Terms number 2 is d over dx 5e power 5x. For this term, we use exponential rule, so the answer is 25e power 5x. Next, term number 3 is d over dx negative ln y. We use logarithmic rule, and the answer is negative 1 over y dy over dx. Terms number 4 is d over dx 5x power 3 plus 2. We use power rule, and the answer is 15x power 2. For step 2, our equation after differentiation looks like 2x cos y minus x power 2 sin y dy over dx plus 25e power 5x minus 1 over y dy over dx equal to 15x power 2. After that, we move all the dy over dx terms to the left side and without dy over dx to right side. The answer looks like negative x power 2 sin y dy over dx minus 1 over y dy over dx equal to 15x power 2 minus 2x cos y minus 25e power 5x. Next, from the left side, we can factor out dy over dx, and it looks like dy over dx open bracket negative x power 2 sin y minus 1 over y close bracket equal to 15x power 2 minus 2x cos y minus 25e power 5x. For step 4, we can solve the dy over dx, but before that, we must move negative x power 2 sin y minus 1 over y to the right, and the answer looks like 15x power 2 minus 2x cos y minus 25e power 5x over negative x power 2 sin y minus 1 over y. We're not finished yet. We can rearrange the answer, and the final answer is dy over dx equal to 2x cos y plus 25e power 5x minus 15x power 2 over x power 2 sin y plus 1 over y.
Now, let's look at question 4. We are asked to use linear approximation to estimate the value of 4 root of 79.99 plus 1, correct to 4 decimal place. Following are the formula and procedure used to solve this question. The formula is fs1 approximately equal to fs0 plus f prime s0 times s1 minus s0. To solve this question, first we must identify s1, then find s0, which is the nearest whole number to s1. Next is differentiate the function fs to find derivative f prime x. After that, substitute all the information into the formula. And the last one is estimate the value. Alright, let's go to the solution step by step and see how we apply the linear approximation formula. First, we need to find x1. Since the question is asking the 4 root of 79.99 plus 1, we add them up. 79.99 plus 1 equal 80.99. So x1 is 80.99. Next, we find x0, which is the nearest whole number to x1. The nearest whole number to 80.99 is 81. So s0 is 81. And step 3 is differentiate the function. Our function is the 4 root of x, which can also be written as x power 1 over 4. The derivative of this is 1 over 4 multiplied by x power negative 3 over 4. The last step is substitute all the information that we have into the linear approximation formula. So we take f of x1, which is f of 80.99, and approximate it as f of 81 plus f prime of 81 multiplied by the difference between 80.99 and 81. Then evaluate the value. The 4 root of 81 is exactly 3. And we calculate 81 power of negative 3 over 4 divided by 4, that comes out to 1 over 108. Then the value of 80.99 minus 81 is negative 0.01. Finally, the 4 root of 80.99 is approximately 3 plus 1 over 108 times negative 0.01, and that gives us about 2.9999. Therefore, using linear approximation, the estimate value of the 4 root of 79.99 plus 1 is 2.9999, correct to 4 decimal place. In conclusion, Differentiation helps us find the rate of change of a function. We use techniques like the power rule, product and quotient rule, trigonometry, exponent and logarithmic rule, as well as implicit differentiation and the differential method. By applying this technique, we can solve many mathematical problems effectively. Here are some of the references source we use to complete our assignment. That's all from us. Thank you.